I am Dr. P. Banu Prakash, working as lecturer in chemistry in PVKN Government College, Autonomous, Chittoor. Today, we are going to discuss about the topic classification of matter, learning outcomes. By the end of this lecture, students are able to understand the concept of matter and non-matter. Students will classify the elements based on its physical state. Students will classify the elements based on their chemical composition. First, let us discuss about the definition of matter. Anything in the universe which occupies some space and possesses some mass is known as matter. For example, iron, calcium, oxygen, water, they are all examples for matter. Then what is non-matter? Anything in the universe which does not occupy space and does not possess mass comes under non-matter. Examples are heat energy, light energy, magnetism, electrical energy. Now let us go through the physical classification of matter. Matter can be classified into 4 types based on its physical state. Number 1, solid state. Number 2, liquid state. Number 3, gaseous state. And lastly, plasma. Let us discuss about the solid state, liquid state and gaseous state and plasma state in detail. In solid state, the matter has definite shape and definite volume. Examples of solid state: most of the metals are solids, ice, rubber, most of the plastics, they exist in solid state. Liquid state: in liquid state, matter has definite volume but does not have definite shape. Liquid occupies the shape of the container. Examples for matter in which it exists in liquid state are water, alcohol, mercury, etc. Gaseous state: in gaseous state, matter does not have a fixed shape or a fixed volume. Examples for gases are oxygen, nitrogen, hydrogen, carbon dioxide, water vapor, etc. Let us discuss about the differences between the solid state, liquid state and gaseous state. Solids have definite shape and definite volume. Liquids have definite volume but no definite shape. Gases does not have a fixed shape and fixed volume. In general, solids have high density, whereas liquids have moderate density, but gases have low density. Solids cannot flow, but liquids and gases can flow. That's why liquids and gases are combinedly called as fluids. Liquids have only one free surface, whereas gaseous molecules have no free surface because they are very free to move, and if you go for the solids, they have n number of free surfaces. In solids, the intermolecular attractions are very high and hence the particles are tightly packed in a systematic manner. Whereas in liquids, the particles are not as closely packed when compared to solids, and due to the little bit weaker intermolecular forces between the particles present in the liquids. In gases, the intermolecular forces of attractions are very weak and hence they are loosely packed and they can freely move. the kinetic energy of the particles in solid state is very low because they are tightly packed, whereas the kinetic energy of particles in liquid state is moderate, whereas in gaseous state the kinetic energy of the particles is maximum, hence they move freely. Regarding the compressibility, solids cannot be compressed, whereas liquids can be compressed to a very little extent and gases can be easily compressible. We can say the compressibility of gases is very high. Therefore, we discussed about the differences between the solids, liquids and gases. Let us discuss about the fourth state, that is plasma state. Plasma is considered as the fourth state of matter. Plasma is considered as the mixture of positively charged gaseous ions and negatively charged electrons. Since plasma consists of the positively charged ions and negatively charged electrons, they are possessing the characteristic property of conductivity. Therefore, the plasma state finds varied applications in different fields. Plasma can be found in fluorescent lights, neon lights, in plasma televisions, in auroras, in lightnings during the heavy rainfall, and in stars and in sun. Let us discuss about the chemical classification of matter. Matter can be classified into two types. One is pure substances, the other one is mixtures. The pure substances are once again classified into elements and compounds. The mixtures are classified into homogeneous mixtures and heterogeneous mixtures. Let us discuss in detail about the pure substances. The substances which have the constant composition are known as the pure substances. Pure substances are generally made up of only one kind of particles. Pure substances have the fixed melting points and boiling points. We can say they have the sharp melting points and boiling points. Examples for pure substances are pure water, pure sugar, pure oxygen, pure hydrogen, etc. If you take a sample of pure gold, it consists of only gold atoms. If you take a pure sample of water, it consists of hydrogen and oxygen in the ratio of 11.1 and 88.9% in the fixed ratio of their masses. Therefore, we can say the pure substances have the definite composition, or we can say they have the fixed compositions. Let us classify the pure substances into the elements and compounds. What is an element? An element is a pure substance which is made up of only one kind of atoms. Or you can say an atom is the smallest constituent particle present in the matter. An element cannot be further divided into its constituent particles, that is simpler substances, by means of any physical methods or by means of any chemical methods. Examples for elements: iron, copper, gold, silver, sulfur, calcium, phosphorus, oxygen, hydrogen. These are all examples for elements. In some elements, atoms exist in monoatomic form, or we can say some elements exist in the clusters of or in the units of monoatomic, or some elements exist as polyatomic units or polyatomic clusters. For example, elements like copper, silver, gold, they exist independently, and hence we can say the atoms of these elements exist independently, and hence they exist as monoatomic units. But the atoms of some elements like hydrogen, oxygen, nitrogen, sulfur, phosphorus, they exist as polyatomic units or polyatomic clusters. Hydrogen exists as H2 diatomic, oxygen exists as diatomic, that is O2, nitrogen exists as diatomic N2, and phosphorus exists as tetraatomic P4, and sulfur exists as S8. Then, in the modern periodic table, 118 elements are present, and these 118 elements are arranged in the increasing order of their atomic number. These elements are further classified into three main types. Number 1, metals. Number 2, non-metals. Number 3, metalloids. And in some cases, the fourth classification comes into matter, that is inert gases. Let us discuss about compounds. Two or more elements combine together to form compounds. Two or more elements chemically combine in a fixed ratio of mass to give these compounds. For example, you take water. In water, hydrogen and oxygen combine together in the fixed ratio of 11.1 and 88.9% by mass. The other examples for compounds are the sodium chloride, magnesium chloride, aluminum carbonate, calcium carbonate, carbon dioxide, sulfur dioxide. Therefore, the compounds are generally made up of two or more similar or different kinds of elements. The compounds does not contain the similar properties as compared to its constituents. For example, if you take water, the constituent elements through which water is made up of is hydrogen and oxygen. Hydrogen is a combustible gas, whereas oxygen supports combustion, but the water which is formed from hydrogen and oxygen is used to put off the fire. It is used in fire extinguishers. Therefore, what we can conclude is the properties of a compound is different from that of the properties of its constituent through which it is made up of. And further, a compound cannot be broken down into its constituent particles like elements or compounds. A compound can be further divided into its simpler substances, that is elements or compounds, through chemical methods or physical methods. For example, if you take water, water can be broken down to hydrogen gas and oxygen gas by using the method known as electrolysis. By supplying electricity, water, which is H2O, can be broken down to two gases, H2 and O2, in the volumetric ratio of 2:1. Similarly, if you take mercurous oxide, HgO, on supplying heat, it will decompose into mercury and oxygen gas. This is known as thermal decomposition. Therefore, a compound can be broken down into its elements or compounds by using the physical methods or chemical methods. The compounds are again classified into two types. Number one, organic compounds. Number two, inorganic compounds. The compounds in which the carbon is present as a main constituent are considered as organic compounds. Examples: all carbohydrates, vitamins, proteins, amino acids, majority of the fuels like diesel, kerosene, petrol, methane gas, they are all comes under organic compounds. Alcohols, they are also class of organic compounds. The main source of the organic compounds are plants and animals. Inorganic compounds, the compounds in which carbon is not a main constituent are known as inorganic compounds. Examples: sodium chloride, sodium sulfate, calcium phosphate, magnesium carbonate, sodium carbonate, etc. The main sources for these inorganic compounds are non-living systems or non-living things. Now let us discuss in detail about the mixtures. A mixture is formed when two or more pure substances are physically combined in any ratio, or we can say in any composition. That means the two compounds are present in variable ratio, or we can say variable composition in the mixtures. Examples for mixtures: air is a mixture of several gases like oxygen, nitrogen, argon, carbon dioxide, water vapor, etc. Sea water is a mixture of several salts and water. The constituent particles present in the compound, that is the pure substances, can be separated by simple physical methods. For example, if you take salt water, it is a mixture of one salt and water. We can separate salt from water just by evaporating the salt water. You will get the salt, and by condensing that water vapor, you will get water. Therefore, by using the simple physical methods, we can separate the constituent particles present in a mixture. But in case of elements, it cannot be split into the simpler constituent particles, that is atoms, by using any physical methods or any chemical methods. Now let us discuss about the classification of mixtures. Mixtures are classified into two types. One, homogeneous mixture. Number two, heterogeneous mixture. Homogeneous mixtures have uniform composition and uniform properties throughout the mixtures. Example, if you take sugar solution or glucose solution, the composition is uniform throughout the solution, and the properties of the solution is uniform throughout the solution. Few more examples for homogeneous mixtures are salt solution, fewer alloys like brass, bronze, stainless steel. Therefore, most of the alloys are considered as the homogeneous mixtures. Soft drinks, they are also comes under homogeneous mixture. They constitute water, carbon dioxide, and artificial sweeteners and some flavoring agents. Then, if you go for heterogeneous mixtures, the composition and properties are different throughout the heterogeneous mixtures. Examples: sand and water, salt and sulfur. If you take sand and water, the properties and composition is different in different parts of the heterogeneous mixture. Another good example for heterogeneous mixture is oil and water. Oil will float on the surface of the water. The composition is different in different parts of the heterogeneous mixtures. Conclusion. We understand the concept of the matter and non-matter. We classified the matter based on its physical state into 3 to 4 types. Number 1, solid state. Number 2, liquid state. Number 3, gaseous state. And number 4, plasma state. We classified the elements, or you can say the matter, into 2 different types based on its chemical composition. Number 1, pure substances, and number 2, the mixtures, or you can say impure substances. The pure substances are again classified into 2. Number 1, elements. Number 2, compounds. These compounds are further classified into 2. Number 1, organic compounds. Number 2, inorganic compounds. And the mixtures are further classified into 2. One is homogeneous mixture, the other one is heterogeneous mixture. Thank you.